Welcome students. There was one derivation left of your capacitance chapter, that is capacitance of a parallel plate capacitor with dielectric slab between the plates. That is, we are taking here a dielectric slab in between. Last time we have taken only dielectric atoms. Okay, now we are taking directly a dielectric slab. Okay, so this is a parallel plate capacitor and in between that a slab is present, right? And in the air the electric field, let it be E naught. In this side air is present, right? Only in between the that is dielectric slab is present. Let inside the dielectric field, whatever electric field is created, let it be E vector, right? And the distance between the plate is D and distance of the dielectric slab is T, right? Okay, so as you know, as we have already studied, so tell me what should be the formula of E naught. That means what is the electric field inside a parallel plate capacitor? The answer is sigma by E naught, epsilon naught. Sigma by epsilon naught, right? You can verify this one by watching the video of parallel plate capacitor, right? Okay, so what is sigma? Sigma is surface charge density. Whose surface? These parallel plates surface, right? If this is sigma by epsilon naught, so I can write what is sigma. Sigma is charge upon area, right? Surface charge density is charge upon surface area, right? So I can write it as Q by epsilon naught into A, right? So for this dielectric slab there will be another electric field E, so I can write your E naught is directly proportional to E. Yes or no? What is E naught? This is your E naught, the electric field inside a parallel plate, that is in air, right, is directly proportional to your what? Electric field in the slab. But how much it will be? It will be K times of your E. What is K times? Dielectric constant times, or you can say your E naught electric field. E naught is the air electric field. It's decreased by which electric field? Slab's electric field. Yes or no? How much time it is being decreased? K times. Okay, in any way you can remember. Okay, so what is your E? E equal to E naught upon K. Okay, right? So you can write it here, where E equal to electric field in slab, right? And what is your E naught? E naught is equal to electric field in air, right? This is the air medium, these are the air mediums, so E naught is the electric field in the air, right? So let us find out our V, right? And what is our main aim? Our main aim to find out capacitance of a parallel plate capacitor with dielectric slab between plates. Capacitance we need to find, right? So we can write, first let us find out V, and V equal to, formula is what? E into dr, right? Minus E into dr, let us take plus as we are taking the magnitude, right? So this implies V equal to E into nothing but D, right? But how many E's are present? There are two E's present. One is E and another one is E naught, right? Two quantities are there, right? So you can write your V equal to, you can write one is due to E naught into, instead of D, what you will write? D minus of T, because E naught is which one? This electric field. So this whole is D, whole distance is D between the plates, and this distance is T. So how much is left? D minus of T, right? What is the distance left? D minus of T. That's why I have written E naught into D minus of T plus E. E is the electric field in where? Slab. So what is the distance? T. So you can write E into T. Clear? Okay. So next you can derive, that is E naught, place the value. Which value? E naught value. Here we have already found it out, where it is E naught equal to Q by epsilon naught into A. Let us place it here. Q by epsilon naught into A into D minus T plus Q by K into epsilon naught into A into T, right? So if you solve, you will get Q by epsilon naught into A D minus T plus of T by K, right? So let us now find out what is capacitance. So capacitance formula is Q by V. So let us place it. Q by, what is the V right now? This is my V. Okay, let us place it here. It is Q by epsilon naught into A D minus T plus T by K. Okay, so if you solve, you will get the answer, as Q will be cancelled, epsilon naught into A will go to upside. It will be epsilon naught into A whole divided by D minus T plus T by K. Okay, this will be your full answer. Now let us go to one basic and very important formula, or you can say very important question, that is why electric field is 90 degree to the surface of conductor. Okay, that is, it is asking us, if this is a conductor, if a charge is present here, why the electric field is 90 degree to its surface? This is our question. So how to solve it? Let us solve. Okay, so if I will take here as a surface of a conductor, okay, and here I will place a charge, okay, and let this charge, electric field is like this, E. Okay, and it is telling us, prove that it should be 90 degree to the surface of the conductor. Okay, so let us do one thing. Let us take it, our E, in this direction, okay, by making some angle, let us say theta. Okay, what is this one? E. Okay, and you know it very well, these are static charges. These are what? Static charges, and they are not moving. If they will move, then you could get a shock, right? So if they are not moving, what is the reason? The reason is that these charges are not applying any force to this charge or neighboring charge, right? That is the force of repulsion. If they are same charge, it must have to repel this one. How much force it will apply? If this angle is theta, it should be QE cos theta. The force should be QE cos theta, and 90 degree to it is QE sin theta, right? So why it is not, why this charge is not moving? Because this charge is not applying any force. Which force it is not applying? QE cos theta it is not applying, right? If it is not applying any force, you can write QE cos theta is equal to 0. Okay, this method is called component method, right? Instead of E, you can write F. You know it very well. Your electric field is nothing but a force upon a unit charge. What is the electric field? Force upon a unit charge. So what is your force? Q into E, right? So now let us come to the equation. QE cos theta equal to 0, right? So your Q and E cannot be 0, right? Yes or no? Your Q and E cannot be 0. So what you can write? Cos theta is equal to 0. So what is your theta? If cos theta equal to 0, then what is your theta? Which degree of theta, cos theta is 0? That is 90 degree. Okay. So now you have proved electric field is 90 degree to the surface of conductor, right? If it is not making any angle theta, so what should be it is making? It should make an angle 90 degree. This is the way to prove, right? And again I am telling you why this charge is not moving, because these charges are static charge and this charge is not applying any force. So the component of force QE cos theta is not working. So QE cos theta is 0. So cos theta equal to 0, because QE cannot be 0. Cos theta equal to 0. So what is your theta? 90 degree, right? So you can write it down by simple words, or you can write it down by your own words, that a static charge cannot apply a force to its neighboring charge, right? And you can write it down or draw it down directly. Draw this one. Okay, write this much, you will get 2 marks easily, right? Only the points you have to write, that is, if your electric field is not making 90 degree, let it makes an angle theta. That much you have to write in this side. Let angle made by E is theta. Okay, then you draw this one, prove this one. So theta equal to 90 degree, and at last you will write electric field is 90 degree to the surface of conductor. Thank you.